Example 3. This one's going to be a little bit different than the ones we've been looking at thus far. And I hope you recognize that as we proceed. So find the area of the region bounded by the graph of the function f and the lines y equals 0. X equals a, that vertical line, and x equals b, the second vertical line. All right, so why is this different? Well, let's look first of all at the graph of this function. All right? I mean, I hope you see that we only have one function here. That's clearly different from what we just did in example number 2. So with that being said, let's go ahead and look at this on our graphing calculator. All right, so I'm going to enter in the function f that we have been given in example 3, and that would be what? X cubed minus 4x squared, and then plus 3x. Let's see what this thing looks like. Ooh. So I tell you what, I'm going to zoom in on this a little bit. See what this does. Zoom in. Hit enter a couple times. Look what just happened there. Ooh, and then right there. All right, so what's happening here is this. What we have to understand is that the graph of this function f from 0 to 1 is above the x-axis. But then the other part of this graph from 1 to 3 is below the x-axis. All right, now really, okay, we only care about the fact that it goes to 2 based upon the question, and I'll show you that question again in a second. But again, to repeat myself, you have to understand the graph of this function f is above the x-axis from 0 to 1. And then on the interval from 1 to 2, it's below the x-axis. So let's see what we have to do based upon knowing that. All right, so based upon what you just saw graphically with respect to this function f of x, let's see how we would set this up. Okay, so the area is going to be equal to what? Well, it's going to be equal to, first of all, the integral of the function f of x, which is this, over the interval from what? From 0 to 1, okay? Note that these are also zeros of the function, all right? Those are actual x-intercept values, right? If x is 0, the function is 0. If x is 1, the function is, again, 0. They're x-intercepts on the graph of this function. All right, so this one I'm able to set up because the graph of f from 0 to 1 is above the x-axis. But now look what I'm going to do next. Remember the second part of this thing, graphically, was below the x-axis, right? So what we're going to actually do is we're going to subtract off that value of the definite integral, because the value of this definite integral will be negative. Because from 1 to 2, all right, we're using 2 because that's what b says. From 1 to 2, when x is any value from 1 to 2, all the y values will be negative. So when you look at the definite integral of the same function, the value of that definite integral will be negative. That's why we have a subtraction right here, because a negative times a negative is a positive. All right? So let's see if we can figure this thing out. Here we go. Area then is going to be what? Well, let's come up with the value of this integral first, and that would be x to the 4th over 4 minus 4x cubed over 3 plus 3x squared over 2. We're going to evaluate this from 0 to 1. Okay, and then we have to do our other one. So I'll tell you what, I'll put the negative down here. So this negative right there, let me highlight it here. This negative right there is going to go right here. Are you with me? This negative right there. All right, so we know we get the same thing. We get x to the 4th over 4 minus 4x cubed over 3 plus 3x squared over 2 over 2. But now our interval is from 1 to 2. Okay, so what does this give us? Here is what it gives us. 1 to the 4th over 4 minus 4 times 1 cubed over 3 plus 3 times 1 squared over 2. That's this part. The 0 will give us a 0, so we don't have to worry about it. And then, oh, I forgot about my red pen. Minus, there's that minus again, right here, right there, bringing it down. That's the same subtraction right there. Minus what? Well, here we go. It's going to be 2 to the 4th. Separate this there. There we go. So it's going to be 2 to the 4th all over 4 minus 4 times 2 cubed all over 3 plus 3 times what? 2 squared over 2. And that's going to be the first part. Then we have to do what? We have to subtract off whatever we got here. So this is actually going to be, well, we'll just see what happens. Just stay with me. So the next part is going to be what? Well, the lower limit of integration in this same integral. So that's going to be, again, 1 to the 4th. I'm using this limit of integration right there. And then over 4 minus 4 times 1 cubed over 3 plus 3 times 1 squared over 2. And then close quantity, then close bracket. So everything here is what is happening right there. Okay, isn't this just a delight? All right, let's simplify all this now. Okay, so this expression, if you run it through your calculator, should give you 5/12. This right here, 5/12. Okay, minus what's happening in the brackets right there. This expression, if you run it through your calculator correctly, gives you a negative 2/3. And then bring down this minus right there. And this expression, we already know what this is, same as what we got here. That's 5/12. All right, so let's finish this thing. We end up getting what? We end up getting 5/12 plus 2/3. Negative is being distributed through here. So a negative is a negative, plus 2/3, and then also plus 5/12. Okay, so if you simplify that completely, you should end up with your correct area that is being created based on the given function f and being bound by x equaling a and x equaling 2. And that area is 3/2 units squared. So much fun. Stay with me. We have one more example to go, and it's unlike any other example we've done thus far.